We cannot see. Have you ever stopped to look at the sky? In the city, it's difficult. The lights of the street, the buildings, the cars, everything extinguishes the stars. But if you go out to a dark place, away from light pollution, and raise your eyes to the sky, there she is, the Milky Way. A bright, almost gooey streak, cutting across the sky like a scar of light. It has been there since humanity existed. The Romans called it the Milk Road. An African tribe said it was the smoke from the fire of their ancestors. Native Americans saw it as the road of sacred animals. But today, we know the truth. The Milky Way is not a band, it's our home because we are not looking at the Milky Way. We are inside it. And this is the first episode of an epic journey. Today, we're going to explore the galaxy we live in, its structure, your center, its spiral arms, and the greatest mystery of modern physics, dark matter. If you like to know where we came from, where we are, and where we are going, this video is for you. And if you haven't subscribed to the channel yet, do it now, because the universe is vast, and we will explore it together. What is the Milky Way? The Milky Way is our galaxy, and in it, we live. But what is a galaxy? It is a huge system of stars, gas, dust, and dark matter, all held together by gravity. The Milky Way has 100 billion stars, a diameter of 100,000 light-years, a mass 200 billion times that of the Sun, and it is in constant motion, spinning like a cosmic disk. And the most impressive thing, the number of galaxies in the observable universe is 100 billion, yes, 100 billion galaxies, each with hundreds of billions of stars. And guess what? Our brain has about 100 billion neurons. Is it a coincidence? Perhaps. But it's a good way to remember. 100 billion, this number, came from a survey done by the Hubble telescope, who pointed to a small region of the sky and counted the galaxies. The result? An ocean of light, an infinite universe. For millennia, the Milky Way was a mystery. People saw that strip in the sky and invented stories, but it was Galileo Galilei who changed everything. In 1610, he picked up a spyglass, which he didn't invent, but was the first to point to the sky, and saw something revolutionary. The Milky Way was not a continuous band. It was made of thousands of faint stars, was the first step towards understanding that the universe was much bigger than we imagined. But one crucial detail was still missing. We live inside the galaxy, and that's a problem. The first map and Herschel's error in the 18th century, the astronomer William Herschel, who was a musician by profession, decided to map the stars around the Sun. He used his gigantic telescope, counted stars in different directions, and concluded that the Sun was at the center of the Milky Way. But he was wrong. Why? Because he didn't consider the dust. Interstellar dust in the Milky Way hides stars, and in the plane of the galaxy, where the dust is densest, it is impossible to see far, so Herschel thought he was in the center. But he was just blind. Kapteyn, the Dutch astronomer in 1922, Dutch astronomer Jacobus Kapteyn did something brilliant. He studied the distribution of stars, took into account the dust, and discovered the truth. The Sun is not at the center of the galaxy. It's on the outskirts. And the center? It was about 60,000 light-years away. It wasn't very accurate. Today we know it's 24,000 light-years, but it was the first step towards seeing the galaxy as it is. Harlow Shapley and global clusters, but the real hero was Harlow Shapley. In 1917, he studied globular clusters, dense balls of up to 1 million stars scattered around the galaxy. He realized something incredible. They did not orbit the Sun. They orbited a point at the center of the galaxy. It was as if the galaxy had an invisible core, and everything revolved around him. Shapley discovered the center of the Milky Way, and it showed that we are very far from it. The structure of the Milky Way today. We know that the Milky Way has a complex structure. The disk, thin 100,000 light-years across, contains the spiral arms where stars are born. Here is the Sun in Orion's arm, the bulge, the central spherical region, full of ancient stars, hotter, denser. Hello, a gigantic sphere around the galaxy, contains globular clusters and dark matter, the great mystery, and in the center, her supermassive black hole, or million times more massive than the Sun. The spiral arms. The Milky Way has 4 main arms: Norma Shield, Cross Sagittarius Perseus, and between them, the arm of Orion, where the Sun is. But the arms are not fixed structures. They are like waves of traffic. The stars come in, go by, and go out. But the wave remains. That's why we see so many new stars. There is where gas compresses and forms stars. The galactic year. The Sun is not standing still. It orbits the center of the galaxy at 220 kilometers, and it takes 250 million years to make a complete turn. This is what we call a galactic year. 50 million years ago, the sun was here. Dinosaurs were appearing on Earth. 25 million years ago, the sun was on the other side of the galaxy. The flowers were coming out, and today, we're back, but never in the same place, because the entire universe is in motion. The mystery of mass. Dark matter now. Let's come to the greatest mystery of modern astronomy. We know that the Milky Way has 100 billion stars. If we add up the mass of all of them, we would have about 100 billion solar masses. But when we measure the total mass of the galaxy, it is 20 times bigger. Where is this dough? We can't see her. It does not emit light, does not reflect light, does not interact with normal matter, but she's there, because the galaxy rotates very fast. If there were no more mass, the stars on the periphery would fly into space, but they don't fly. So there is something invisible holding it all together. We call this dark matter, the rotation curve, proof of dark matter. According to Newton's physics, the further away from the center, the lower the speed of the stars. It's like the planets. Mercury is fast, Neptune is slow, but in the Milky Way, stars on the outskirts rotate as fast as those near the center. This is only possible if there is much more mass than we see, and this mass is in the halo, surrounding the galaxy like an invisible bubble. It's dark matter. Baryonic matter is dark. Matter, everything we know, our stars, planets, us, is made of baryonic matter, protons, neutrons, electrons. But this matter represents only 15% of the galaxy's mass. The other 85% is dark matter, and we don't know what it is. Will it be a new particle? A cosmic field? Something beyond current physics? Nobody knows. But we know it exists. Satellite galaxies and cosmic cannibalization. The Milky Way is not alone. It has satellites, large Magellanic Cloud, small Magellanic Cloud, Sagittarius, dwarf galaxy, which is being swallowed right now. These small galaxies are captured by the gravity of the Milky Way and end up merging with it. It's like cosmic cannibalism. And we believe that in the past, the Milky Way has already devoured dozens of smaller galaxies. That's how she grew up. What would the Milky Way look like from the outside? We will never be able to leave the galaxy to photograph it, but we can compare. Galaxies like NGC 1300 or Messier 83 are very similar to the Milky Way. They have a bright core, a central bulge bar of stars, and spiral arms coming out of the bar. The Milky Way is likely to be like this. What if someone in another universe looked this way, would see a spiral galaxy spinning silently in the void? The future of the Milky Way. The Milky Way is not standing still. It is moving towards the Andromeda galaxy. In 4.5 billion years, the two galaxies will collide. But it won't be an explosion. It will be a gravitational dance. The stars are so far apart that rarely collide, but the structure of galaxies will be transformed, and the sun, it will probably be thrown to the periphery, but it will still be there. We are the galaxy. The Milky Way is not just an object in the sky. She is our home. Every star, every planet, every carbon atom in our body came from a star that died billions of years ago. We are not separate from the universe. We are the universe looking at itself, and as long as we keep asking, what is the Milky Way? What is dark matter? Where are we going? We will be fulfilling our role. If you liked this video, imagine what we will see in the next class. Galaxies, types, collisions, and the expanding universe. Leave us a comment. What do you want to learn about the universe? And if you haven't signed up yet, sign up now, because the next video could change the way you see the cosmos. Activate the bell, share with someone who loves the universe, and until the next journey.